Get enough windows out of the way. Okay, well, hello everyone. So today, I want to go over when the thing went out, an invitation went out, I mentioned that wanted to kind of compare and contrast EPA SWIM with what was in Autodesk Storm and Sanitary Analysis. So I just have I have SWIM loaded right now. I also have Autodesk Storm and Sanitary Analysis. So for those of you who are not familiar with Autodesk Storm and Sanitary Analysis, it is actually a free program that is a separate executable which is installed with Civil 3D. So whenever, say if you have a network or CAD administrator, as long as when they installed Civil 3D on your machine, you would already have access to this. And what it does, well, it does several things, but I guess the one point that is important for this is SWIM, EPA SWIM, is a program, obviously, that's open source, so the source code is given out with the program, and that is convenient because the actual engine for SWIM 5 is inside of Storm and Sanitary Analysis. The benefit being that if, say, I compare SWIM right now, I'm kind of limited. I don't see any import options. I don't really have a lot of native CAD tools available to me. I can obviously sketch everything out, run my model, but if I've already gone through the trouble of creating my entire model as a pipe network in Civil 3D, why would I, re-sketch the thing out as a schematic? Doesn't make any sense. So I'm actually going to show you, I'll go through the process of how we're going to take a drawing, a pipe network from Civil 3D, import that into Storm and Sanitary Analysis, run our results, and then I'm going to also go into a little bit about the actual design of pump selection in a wet well, because just like EPA SWIM, we have the advantage of not only being able to do gravity pipes, but also I can do pumps and pressure mains and things like that. So before I jump in, for those of you who are familiar with EPA SWIM, I'm sure you're familiar. I have, say, I add a couple pieces from my toolbar up here. Maybe if I just add 2 junction objects and then select a conduit, it will intelligently see the snapping, by location, and then snap the whole thing together. I can double click on a junction, and if I weren't working on, if I hadn't just done this on a computer with 2 screens, when I double click it, you would see that a dialog would come up, and it would show me, the statistics of my junction. So, things like my rim and my invert. And then after I run it, I could also see in there that I have my results from the run, the maximum water elevation, things like that. And I can access all of my objects here as a list. Not only down here, I can see the list of the number of conduits I have, but I could also double click in here for my links, and I could see, conduits. I keep using the word that SSA uses, which is links. If I double click this, I could see all the information right there. So all of my vitals right here versus all of my modeling components and how I'm actually going to run my model, and then how I look at it in profile. So why am I, obviously you're here for Storm and Sanitary Analysis. Why am I talking so much about EPA SWIM? Well, you can take a mental snapshot of this in your mind and then consider this. I think you could see the 2 are very similar in layout, and they operate in the same way. I can take a junction or a couple junctions, and I can click a link, same as a conduit, and it works in the exact same way. Like I should have seen in EPA Swim, if I double click an object, I get a dialog with all of the properties of that object. And I can see all of my objects as a list view if I double click over here. So if you are already a user of EPA Swim, you have the benefit of ostensibly already knowing the layout and workflow of Autodesk Storm and Sanitary Analysis with a couple wrinkles mixed in. Because the benefit that I have, one of the main benefits of Storm and Sanitary Analysis is compared with EPA Swim. If I go up to my project options, I can see I have a whole bundle of different hydrology methods that I can pick from, and I can mix and match them. So I could, I could actually run an overland flow model using rational method, and then I can also separate out what type of link routing I'm going to use in my pipes. So I'm not going to get into too much detail into the differences between them, but know that the hydrodynamic is actually the St. Bennett equation, so it's the one we're going to use for our pressure network and our lift station design, because it's the only one that can do reverse slopes, whereas kinematic wave is just momentum equation, and if I had reverse slopes, I would actually, the results would fail out. So it's actually kind of nice, as an aside, when I'm going through my network, if I have, even if I'm going to include a force main, sometimes I begin by, after sketching out my network, if I want to make sure I didn't accidentally put any reverse slope pipes in, I'll run the model as kinematic wave. If it fails, it'll show me exactly where it failed. I can change my slopes, fix my inverts, do whatever I need to, and then when I rerun it, as long as it completes, I can then, on the fly, change my method to hydrodynamic, and away I go. So let me start and open a lift station that I've already laid out, or at least the upstream portion of it. So I actually took, I used Infraworks, another Autodesk product, and I grabbed an area that I was sort of familiar with, basically at random though. And the area, I grabbed from it a tin surface. I grabbed an aerial image. It gave me all of the alignments of the roads. It actually even tried to put in corridors for those roads. So if you haven't checked out, if you have not checked out Infraworks in a while, they've actually made updates in the last couple iterations that are pretty impressive and extensive. So it actually basically pulled everything I needed to just start my network. And then I dropped a pipe network in along here. And again, because I have my surface, I can see by my tooltip, anywhere I have my tooltip, that where my surface elevation is. When I inserted my sanitary junctions, it placed those junctions at the rim. And I also set up rules for minimum and maximum slopes along my pipes, so that when I dropped it in, it would try to meet the minimum slope that I had set based on 10-state standards. And it put in no sumps, because I am assuming that each one of these junctions has a formed channel in it, and I didn't want, I don't actually want water to pool in those. So I set it up right now all 12-inch concrete, actually, except for this one. I'm actually going to take this, and before I mess this up, I'm going to swap this out with an actual 12-inch concrete so I don't get any surprises. Okay. So now that I've laid out my network, and I'm going to close Storm and Sanitary Analysis because I don't want to have two sessions of it open at once. That's just my preference. So right now, if I'm at the point where I've laid out my network, I've looked at my profiles, made sure that I'm meeting slopes, I don't have, kind of taken it, don't have any back slopes, everything looks good for my initial run. When I'm ready for it, I'm going to take what I have here and I'm going to just export this directly into Storm and Sanitary Analysis. What I've done for the actual lift station area is to simplify things. I have placed in what's actually going to be my wet well as a manhole. Now, just as in EPA SWIM, I can take a junction and convert it to a storage unit. I'm going to take advantage of that, the fact that I can directly turn this into a Storm and Sanitary Analysis model and convert that after the fact into a storage unit. And then this little stub right here will be the beginning of what will eventually be my force main. So let's try that right now. On the Analyze tab, if I hit Edit in Storm and Sanitary Analysis, it's going to do two things at once. It's going to export this pipe network as a HydroFlow STM file, which HydroFlow is another Autodesk tool. If you do use HydroFlow, you might be familiar with that. But I'm going to export that file. It's going to automatically import it into Storm and Sanitary Analysis, and it's going to bring in this CAD file as a background. So I'm going to get my aerial, I'll get my alignments, everything else, all as a background that I can use. So I'll try that now by hitting Edit in Storm and Sanitary Analysis. I'm going to choose which network I want. I only have the one. I'm going to say OK, and just wait for it to run through its iteration. Now here, it asks me, do I want to create a new project or do I want to merge it with an existing project? If I already have some model, it could have been an EPA SWIM model, could have been any number of models, and I'll show you all of the different types of formats that I could actually import into Storm and Sanitary Analysis. I could merge them into one file right now, but I don't have that, so I'm just going to create a new project. All right. I can see my log file. I can check, it would tell me if there were any errors. It tells me a few things that it did, changes that it had to make, if it did make any. Let's zoom in and look. Okay, so here is actually all my pipe network. Those purple lines that you remember from the drawing have now just become a background CAD image. And my junctions and pipes themselves have all been brought in directly to Storm and Sanitary Analysis with their associated invert and sizing information. I didn't have to change anything. There's also in Civil 3D, I could have set up all of these different parts with their own Manning's coefficient, and where applicable, when I go to change it, they're either Hazen-Williams or Darcy-Weisbach coefficients. I could have all that set up for me ahead of time, so then when I import it, it brings all of that information in. So it's depending on how much setup I do ahead of time and how sophisticated you are, you could really make this a very quick process. right now my aerial is a little, it's a little dark. It's kind of getting in my way, and I don't need it for right now. So if I go to View and Layer Manager, it works just like AutoCAD, where I can take CAD layers natively, and I can turn them on and off. So I'll turn off my ortho layer. That's better. And now I can see what I'm working with. Okay. So notice at the end of my stub, it automatically put in an outfall because it tries to give me a solution that it can work with. I have to have an outfall to have a solution. So before I can do anything else, I mean, we already kind of spot checked a few of them. Like I said, everything was 12-inch concrete. My Mannings looks okay. The diameter is good. I know already that the inverts are fine. And the lengths are brought in from Civil 3D. And this is actually, because I brought this in from Civil 3D, this is a one-to-one model. If I say, drew a link from here to here, I could just draw it in this model and it would automatically compute the length of it. And when I'm done, obviously I set the invert, set the sizing, things like that. I'd run my model. Once I got my results, I could take this and import it back into my original drawing, and it would change the geometry and add a link from here to here. So it's very dynamic. Any changes I make in here during my analysis based on my results are going to then flow back into my network in Storm and in Civil 3D. The first thing I want to do, though, before I run anything else, is I want to set my project options. Project options are, because we have so many different methods available to us for both hydrology and hydraulic routing, I need to set those up ahead of time. And what I do in here actually affects what I see. So it's usually, if I'm expecting, say when I double click on a junction, if I'm expecting to see a certain list of fields available to me that I don't see, or if they're grayed out like this, what I see is actually affected by what method I've chosen. So I want to make sure that I do this the first time, right before I start anything, because otherwise everything I put in is going to be erroneous. Flow units, I'm actually going to change this to gallons per minute. I'll leave my elevation type as elevation. I could set it to depth if I was using offsets, but I'm going to use actual elevations. My hydrology method will be EPA swim. I'll show you what that does. And my link routing will be hydrodynamic. Okay. So now that I've changed those options, when I go into the junction, I actually have a section up here for external inflows, which if you're using EPA swim, you might already be familiar with some of the things it can do. I could actually set a rainfall-dependent inflow infiltration hydrograph right here. I could create one and then assign it to specific junctions. So if you have, if you're doing a sanitary sewer overflow analysis, you already have flow meters in place, and you have your hydrographs in place, I could place them in here and set my sewer shed area, and it would, run based on the time frame that I've given it. I'm not going to get to that level in this presentation, so I'm not going to be using these, but I just want you to be aware that here, that is where they are. In this case, I'm just going to worry about my dry weather flow. So I looked at this area, and I just kind of came up with, I think I had like 10 houses or so. I can't remember how many houses there were per node, divided that out by, like 100 gallons per capita per day or some standard estimate, and I came up with a flow of 1.74 gallons per minute on average. After that, I also need a time pattern, right? I need my diurnal pattern. When I click Add, there's actually a database inside of Storm and Sanitary Analysis that gives me a sample one. But as far as samples go, it looks pretty realistic. So I'm just going to use it for now. So I've set that for this junction. Which junction is that? Well, if I click around here, I might not, it looks like I don't have flashing set up. Oh, I do, okay. You can kind of see it right there. This one that's flashing is the one I'm looking at. If I select a different one from the list, it'll also flash to show me. What I can do at this point is if I select a junction, I'll right click and go to Copy Properties. Copy Properties will actually copy everything that I have, like external inflows, if I had treatments, anything that's in these submenus, it's going to copy those, and then I can paste them to another junction. So I'll just select this, right click, go to Paste, do the same thing over here, right click. I can also just press A in this case. So right click A, right click A, right click A, etc. So I can do all that, and once I have put in all my flows, then I'll come down here and then I can change things to the wet well. So I've actually done that ahead of time and copied and pasted everything in there. I'll just open the model that already has those completed. All right. So I'll double click the junctions up here and I'll just look. I'm going to scroll through these and make sure that all of my lateral inflows are set to yes. That's the indication that at least something has been set here, and since I copied and pasted it, I know that it's the same value. I can't fat finger a copy paste. And then I don't have any inflow directly into my wet well, which makes sense because my wet well is going to be dependent upon my system. But the wet well is not yet a storage node. So I'm going to right click, say convert to storage node. Okay. So when I double click on my storage node, I can actually use a stage storage curve. So if this were a pond or something like that, I could set that up. I can actually import a stage storage based on the contours that I created in Storm and Sanitary, in Civil 3D. But in this case, I'm just going to use a constant area, 76.4. And so these are a little more even. I'm going to reset. My inverts here as well and set this to 668. And then this one doesn't really matter what this is, but I'll just say 681. Okay. All right, so now that's done. If I click on this conveyance link, it's still set as a standard gravity pipe. What I want is I want my storage node to be connected to a pump, and then that pump is going to be connected to my force main, which will then take my outflow to my water treatment plant. So I'm going to go up to junction, and I'm going to hover over, get close to this pipe here, and once I click, it's going to ask me if I want to split this pipe right there. I'll say yes, and now it's logically split the pipe and interpolated the rim and the invert at that location. So it's pretty close, but I'm actually going to set this right now to, let's say, this is actually 670, and make my rim, oh, yep, 676. Okay. It also defaulted my initial water surface elevation, but I'm going to assume this is empty, right, at the time that I'm going to start my analysis. So I'm just going to copy and paste whatever the invert is and set it as the initial water surface elevation. Okay. I'll go back in here, and I will do the same thing here. Just say it's empty. If my pipe is above that, if my pump, wherever it connects, is above that, I would probably just set it and assume that the invert of wherever the pump input is my water surface elevation. But we'll not worry about that right now, because I've actually set it. I'm going to set the pump input to the bottom of my wet well exactly. Okay, so that looks good. Now, same with EPA swim. I select my conveyance link, right click, and convert to a pump. Here's my pump. Now the pump, I can also, if you like standard schematic type look of it, I could add vertices to it and bring it out. So I have one pump here. I could have pumps in parallel, so I could add another pump link here. I could have them in series, so from one storage node to a secondary storage node, and so on. But in this case, let's just, for simplicity, I'm just going to assume it's a single pump unit. I'm going to set the initial status to on and the pump mode to design. So this is basically just going to turn my pump into a pass-through. Any water that comes in here will be ejected through my pump and then go out into my force main, which I still need to set. So let's say this is, instead of a circular gravity pipe, this is a circular force main, 4-inch diameter, and then I give it a Hazen-Williams factor, which I can actually look up from here if I want to. But I'll just set this to 145. And I'm going to reset, again, I'm just resetting the inverts for this demonstration so that the numbers come out more evenly. 670, 710. Length. Okay. Double check. Everything looks okay. All right. The last thing I want to do is I want to look at my pattern when I look at my hydrograph and see what's happening over the course of a day. So if that's the case, I want to make sure that my analysis duration is going to capture not only my entire run, but a little additional time so that my analysis has time to drain, basically. So I just set this to a day and 6 hours. That should be fine. We're not using any rainfall dependent infiltration. If this were a combined sewer system, I could also model it that way and include sub-basin areas, which I think are called sub-catchments in SWIM. Let's see. Yes. Do that and then drain them into specific nodes, or I could have additional catch basins to go to it. So I really can blow this out as much as I want. All right, one last look before I finally come up and click an initial run. Okay, so the analysis completed, which is good. But I see right here that this link is blue. Blue means flooding. So anything that's flooded, typically I'm going to lose anything that goes over the rim. Any hydraulic grade that's over my rim is considered loss, minus anything that goes through my force main. But in this case, if I look at the time series plot, which is my hydrographs, I can see the flow for my links going through my pump. So here's what's being ejected out of my pump. And let's actually compare that with, let's compare what's coming into this wet well versus what's going into this junction. Let me turn my labels on so that I can see the IDs. Okay, so it looks like wet well and junction 1. Let's compare those two. Here's wet well, here's junction 1. Junction 1 and wet well is the same, which is what we'd expect. And outfall is nothing. So we've lost all of our flow due to surcharging. It's basically flying out of the top of our, out of the top of our manhole. That's because, just like EPA SWIM, junctions don't have volume. They're just, basically sections that you can see the hydraulic grade line. It's kind of like a piezometer. What I want to do in this case is I just want to make sure that my allowable surcharge elevation is higher than what it actually reaches during the analysis, because this is a solid lid, right? It's just probably a pass-through right here. So I'm going to set this to 800 right now. So that's going to be definitely going to be higher than my surcharge elevation. And when I run it this time, I see that I have surcharge, but it's allowable surcharge. And if I compare the inflow to that node right after my pump to my outlet, there we go. So now my system's working. Okay. Let's take a look at one more thing from this time series plot. It looks like during my analysis, let me go back to the pump itself, and let's find the peak flow of the pump. Looks like 62 gallons per minute. So right over here, if I get close to it, click on it, yep, 62. So it looks like right here is my peak. It must be the peak inflow. It's also my peak outflow. So what I'm going to do is I'll check the head at this point of my wet well, and then I'll check the head at my outflow. So it looks like, maybe I'll compare it with my outfall as well. Okay. Oh, where are you, wet well? Down here somewhere. Point is, I can see my elevation right here. This is the elevation of my outfall, right? 710. Up here, where I had my peak outflow of 63 gallons per minute, says my head is 718. So it looks like I've got a head loss for that flow rate of, the 63 gallons per minute. I have a head loss of about 8, dynamic head loss of 8 feet of head. And then I need to push a total head from the difference of my, wet well elevation down here to all the way to the top. I can't remember what that came out to. Not a massive number, but I kind of came up with a rule of thumb. It looks like I want to see what happens to my system if I try to eject, let's say, I try to push 100 feet at, what did I end up coming up with? 80 gallons per minute. So how do we do that? I come in here, And instead of design, I'm going to select a pump curve. I don't have a pump set up right now, so I'm going to click this ellipsis, and I'm going to add a pump curve. Now you can look up in the help file what each type pump is, but basically this is a volume flow inline pump. Here's a volume flow, or a depth flow inline pump. So it's just basically I'm setting up logic for whenever the depth reaches a certain level in my pump. I'll tell it when my pump's going to turn on and what my flow is at that point. So I'm just going to say for everything in between, I want to make sure I get this in the right order. I'm just going to have it be a variable speed pump. And the whole thing is just going to be one straight line at 80. No matter what, I want to see what happens right now if I pump 80 gallons per minute. And then I'm going to set this up as well and tell it I want to start up at 8 feet of depth in my wet well, and then I'll turn off when my water level reaches 2 feet of depth. Okay, so let's see what happens with that. Give it another run. And now let's look at the results in the time series plot. So if I look at head, here's the head right at my outfall, or excuse me, right at the downstream node. There's the elevation I need to meet for static head. So it looks like up here, the difference between here and here is the static head. And then looks like I need an additional 11 at 80 gallons per minute. I need to, basically have an additional 12 feet of head pressing it out. So, when I'm going to use this information and say, hey, just so the thing dribbles out of the end, I need that many feet of head for my pump, and I can use this actually as my pump selection. Oh, I might even use this peak over there, but that might be more of a non-dampening inertial term that I forgot to set. So I'm guessing it's more likely here. Okay. So if I made any changes to my system, I can, at this point, say I've run my analysis, everything works out. I can output my file, export it as a hydroflow storm sewers file. So we'll call this proposed. And once it's done that, come back in here, insert storm sewers. Get it to the right folder. And in this case, I made strange changes to it, so I shouldn't have done it this way. If it were, I missed a step. If I found anything wrong with the gravity portion of the network, had I imported it at that point, a dialog comes up and asks you, do you want to update your existing network? But I did things out of order because I had already added the force main, and a pipe network doesn't have force mains, so I thought it was a different network, so that was the issue there. But just know for the gravity piece, when I insert it back in, and also because I exported that model from a different drawing entirely. Same drawing, different location. I think that was also an issue. Anyway, but you get the point, I think. Now, I guess we can open the floor to questions.